Hello everyone, my name is Carla Rodriguez. I'm going to tell you about study SERS in semiconductors purified. SERS is a technique in which the sample to be analyzed is brought in contact with a raw or nanostructured surface to detect molecules in small quantities, where the localized surface plasmon for the enrichment of the electromagnetic field is mainly responsible of the amplification of the Raman cycle. In this work, we studied electromagnetic interactions of the golden nanoparticles with the properties of the gallium indium arsenic quantum dots that could be modified to certain amplification factor in the HSA molecule. Indium arsenic semiconductor quantum dots were self-assembled by molecular beam epitaxy under different growth conditions in order to promote a variety of morphologies of the sequence absorption of the golden nanoparticles. Once removed from the ultra-high vacuum environment, the quantum dots templates were characterized ex situ by atomic force microscopy to obtain information on their morphology and distribution before and after the deposition of the golden nanoparticles um, of 5 nanometers bulk in the nanocomposite. For the position of the golden nanoparticles, the process known as copy brand has used. Finally, with the same method, a drop HSA was deposited in aqueous solution with 1:1 ratio. Raman and SERS measurements were performed with a Hirova Explorer using a green laser source in solid sample with a 100x objective, with a time of 30 seconds and a convolution of 5 spectra. In the picture 1, we have semantic diagram quantum dot structures. In the picture 2, I, we can see a description of the process uh, of the deposition of the golden nanoparticles. In the picture of the right, we can see the picture of the samples with the position of the golden nanoparticles in solution. In the picture 4, we can see the samples by ASM when before and after of the deposition of nanoparticles. We can see a little accumulations or agglomerations of the material. After the deposition of nanoparticles, golden nanoparticles, also we can deposition HSA in solution aqueous from an analyzer in Raman. We found representative bands were observed in the Raman spectra attributed to protein, for example in 946, the stretch mode of the CC. Carbon. In the picture 5, the region from 800 of the 1800 was analyzed since it forms a large part of the fingerprint region for most biological samples. the semiconductor will have a signal in range of 800 to 1800. Uh, we can see in the picture of the right in Raman the quantum dots don't have a signal. In the picture 5, you can see amplification in the molecule HSA molecule. In this study, quality characterization of the golden nanoparticles in indium arsenic quantum dot system is a proof of concept was carried out. It is a found involvement of SERS is caused by combination of several types of resonance in the combined system, surface excitation, charge transfer, and molecular resonance. Furthermore, considering the contributions involved in product of SERS, we studied the mechanism through achieve the interaction between nanoparticle semiconductors, nanostructures, and HSA. The findings of the study open the possibility of the design team evaluating and synthesize efficient SERS substrates for the use of biomarkers.